Hello and welcome to my video. This week I am planning to do what I call a mini-series where I upload a couple of videos with the same topic for the entire week. In this particular week, I am going to upload 3 videos about elementary functions. The functions are actually pretty simple. They are basically linear or quadratic functions at most, but instead I am going to focus on combination of those functions with special features, for example, like absolute values, composition, or inverse of such functions. So please keep track of my channel for those problems. And let us dive into our first problem of the week. Suppose fx equals x squared minus 6x plus 9 and gx equals minus x plus 5. Draw the graph of y equals hx, where hx is given as 1/2 times fx plus gx minus absolute value of fx minus gx. And as the thumbnail and the title suggest, I am going to present you 2 methods. First, I will introduce the most straightforward and general method when dealing with absolute values, and then I will move on to the second method. The first method is directly substitute fx and gx in the definition of hx. So hx equals 1/2 times, here fx plus gx is x squared minus 7x plus 14 minus, then we have absolute value of fx minus gx, and fx minus gx is x squared minus 5x plus 4. So we have absolute value of x squared minus 5x plus 4 here. Therefore, we must divide cases according to the sign of x squared minus 5x plus 4. So first, consider a case where x squared minus 5x plus 4 is positive or 0. If we factor the left-hand side, this is equivalent to x minus 1 times x minus 4 is either positive or 0, which is again equivalent to x is greater than or equal to 4 or x is less than or equal to 1. In this case, we have minus x squared minus 5x plus 4 here. So we have 1/2 times this x squared term cancel out, and we have minus 2x plus 10. So we have minus x plus 5. So we have this expression in this interval. Next, consider a case where x squared minus 5x plus 4 is negative. This is equivalent to x minus 1, x minus 4 is negative, which is equivalent to x is greater than 1 and less than 4. Here we have to reverse the sign, so we have plus x squared minus 5x plus 4. So we have 1/2, 2x squared minus 12x plus 18, which is x squared minus 6x plus 9, which is x minus 3 squared. So this is a convex parabola with point 3, 0 as a vertex. So we have that graph in this interval. Alright, so we have obtained hx like this. So the graph looks as follows. First, in this region, we have minus x plus 5, which is linear graph. Next, in this region, we have a parabola, x minus 3 squared. And this is the graph of y equals hx. So that was the first method. Now let's talk about the second method. To understand the motivation for the second method, let us take a look at our result, the expression for hx. Notice that hx is minus x plus 5, so hx is actually equal to gx when x is greater than 4 or less than 1, and hx equals x minus 3 squared here, so hx equals to fx when x is greater than 1 and less than 4. Is this a coincidence? Well, obviously not. These are the direct result of how this hx is defined in the first place. Now, what does this function hx mean? Here, let's divide cases like this. First, if fx is equal to or greater than gx, then hx is equal to 1/2 fx plus gx, and we have minus fx minus gx here. So here, fx cancels out, and we simply have gx. Next, when fx is less than gx, then we have plus fx minus gx here. So this time, gx cancels out, and we have fx. Therefore, hx represents the lesser of fx and gx, or non-greater one between two functions. We can also write this as hx is basically a minimum value between fx and gx. Therefore, we can draw the graph of y equals hx like this. First, we draw two graphs of y equals fx and y equals gx. Then we simply select the lower part between two graphs. Then this graph right here is y equals hx. Now before we go, let us just quickly check our answer using the Desmos graphing calculator. Here we have two graphs, fx and gx. Now if we define hx, well actually h1x here, as given in the problem, then plot this function, you can clearly see that it is indeed the answer that we have already obtained. Moreover, hx is simply the minimum between two graphs, so let's delete this. And if we define h2x using the minimum function and plot this graph, you can see that the graph is exactly the same as the previous one. And that was all for this video. Thank you for watching, and please subscribe for more function problems, and I will see you in another video.